The universe began with an unimaginable explosion, a moment of creation that defies comprehension. Scientists call this event the Big Bang, a term that captures the explosive birth of everything we know. It happened nearly 14 billion years ago, a time so distant it's almost beyond human understanding. In the blink of an eye, the universe went from smaller than an atom to an incomprehensibly vast expanse, expanding at a rate that boggles the mind. The early universe was incredibly hot and dense, a seething mass of energy and particles. As it expanded, it cooled, allowing the first particles to slow down and combine. This cooling allowed matter to form, creating the building blocks of everything we see today. The first atoms were hydrogen and helium, the simplest elements, which would later give rise to more complex forms of matter. Gravity then began to work its magic, pulling these atoms together with an invisible force. It pulled these atoms together into gigantic clouds, vast regions of gas and dust. These clouds, called nebulae, would become the birthplaces of stars and galaxies, the cradles of cosmic creation. Our own Milky Way galaxy formed from one of these ancient nebulae, a swirling mass of stars and planets. Within the Milky Way, a small, unremarkable cloud of gas and dust began to collapse under its own gravity. This event, about 4.6 billion years ago, marked the beginning of our solar system, a new chapter in the cosmic story. It was a chaotic time, with particles colliding and clumping together, eventually forming the planets, moons, and other celestial bodies we know today. Imagine a swirling disk of dust and gas, a cosmic maelstrom. This was our solar system in its infancy. Particles, drawn together by gravity, started to collide. These collisions, initially gentle, became more frequent and violent. Small particles stuck together, forming larger ones. This process, called accretion, is like building a snowman, one snowflake at a time. Over millions of years, these clumps grew larger, forming planetesimals. Planetesimals were like the seeds of planets, rocky bodies several kilometers across. The early solar system was a chaotic shooting gallery. Planetesimals constantly collided, some shattering into pieces, others merging to grow even larger. In this cosmic dance of chaos, one particular planetesimal, destined to become our Earth, began to dominate its region of space. The early Earth was a very different place than the world we know today. It was a hot, molten ball of rock, constantly bombarded by asteroids and comets. As Earth grew larger, its gravity increased. This allowed it to attract even more planetesimals, adding to its growing mass. The constant bombardment generated immense heat, melting the young planet's surface. Denser materials like iron and nickel sank to the center, forming Earth's core. Lighter materials like silicon and oxygen rose to the surface, forming the mantle and crust. This process, called differentiation, gave Earth its layered structure. The early Earth was still a violent and chaotic place. The final major event in its formation was a cataclysmic collision with a Mars-sized object. Section 4. A world of fire and water. Imagine a collision so powerful that it melted the Earth's surface, turning it into a seething, molten landscape and blasted molten rock into space. This is the giant impact hypothesis, a theory that explains the dramatic events that shaped our planet. The debris from this colossal impact, caught in Earth's gravity, gradually coalesced to form our moon, our constant celestial companion. The early Earth was a world of fire and volcanoes, with volcanic eruptions shaping the landscape. Volcanic eruptions spewed gases from the planet's interior, forming the first atmosphere, a thick and hazy shroud around the young Earth. This early atmosphere was very different from the one we breathe today, lacking the oxygen that is essential for most life forms. It was rich in carbon dioxide, water vapor, and nitrogen, creating a greenhouse effect that kept the planet warm. With little to no oxygen, the atmosphere was hostile to life as we know it. As the Earth gradually cooled, water vapor in the atmosphere condensed, forming clouds and eventually rain, a process that would transform the planet. Torrential rains fell for millions of years, carving out the landscape and filling basins with water. These rains filled the first oceans. These oceans, initially hot and acidic, were the birthplace of the first forms of life. Over time, these primordial waters would become the cradle of life, setting the stage for the evolution of the diverse ecosystems we see today. Section 5. Life's first breath. The emergence of life on Earth is one of the most remarkable events in the history of the universe. It marks the beginning of a journey that has led to the incredible diversity of life we see around us today. In those early oceans, under a hazy sky, the first life forms arose. These primordial waters were the cradle of life, nurturing the very first organisms. These were simple, single-celled organisms, but they possessed the extraordinary ability to replicate and evolve. Despite their simplicity, they were the pioneers of life on Earth. Over billions of years, life diversified and complexified. From these humble beginnings, a vast array of life forms emerged, each more complex than the last. Photosynthetic organisms evolved, releasing oxygen as a byproduct of their energy production. This was a game changer for life on Earth. This oxygen gradually accumulated in the atmosphere, transforming it from a toxic soup to the air we breathe today. This change was slow but monumental. This transformation, known as the Great Oxidation Event, was a pivotal moment in Earth's history. It set the stage for the development of more complex life forms. It paved the way for the evolution of more complex life forms, eventually leading to the incredible diversity of plants and animals we see today. This journey from simple cells to complex organisms is a testament to the power of evolution.